Phosphate chemical is added to the boiler water to react with calcium and magnesium, preventing scale buildup on the boiler tubes and maintaining efficiency. Inside the boiler, calcium and magnesium ions form hard scale. Adding phosphate treatment triggers a rapid reaction. This results in calcium and magnesium phosphate. When PAC enters the boiler water, aluminum ions coagulate suspended impurities. But under intense heat, this same reaction forms a thick, glass-like mineral scale on the tubes. Inside the high-heat environment of a boiler, Poly Aluminum Chloride is introduced. Aluminum ions react with sodium, forming a complex mineral known as analcite. Inside boiler tubes, dissolved minerals can crystallize. Analcite formations harden into this crystalline layer acts as a heavy insulator, causing the metal to overheat and risk failure. Introducing PAC into a boiler is highly dangerous. It causes rapid scale buildup and severe overheating. This leads to catastrophic tube failure. While PAC can effectively settle ions, it also poses a serious risk of forming highly insulating hard scale on your boiler tubes. While PAC settles ions, it forms dangerous analcite scale. Polyacrylate keeps sludge soft and dispersible for easy removal through blowdown. Inside the boiler, calcium and magnesium ions form hard scale. Adding phosphate treatment triggers a rapid reaction. This results in calcium and magnesium phosphate. Over time, soft sludge builds up on boiler tubes. Polyacrylate is introduced to the water. It disperses the sludge, keeping surfaces clean. Polyacrylate disperses sludge particles. On the right, they settle automatically.